Hello guys, welcome to the OCR AS Level 2022 Paper 1 MCQ multiple choice question breakdown. We're going to go through all 20, stay tuned, have a go as we go along and see where you can pick up marks. And without further ado, let's get going. Right, question 1. Which of the following could be the wavelength of UV radiation? Okay, so it's not going to be A, that's far too, that's not in the range, that's far too big I think. B is far too small. C is far too big. And D appears to be right. Okay, so how do I know that? Well, I'm not going to go through the exact values of the EM spectrum because that's something you'll just have to learn. There's no real trick I can tell you. However, I can give you a trick about the placement on the EM spectrum. And that's using an acronym. Raw meat is very unsanitary except giraffe, right? It's a bit funny, but it works, right? We've got radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays, right? So at this point, at radio, we have the highest wavelength, right? And here at gamma, we have the highest frequency, right? I'm just going to call that F. Now, as you go along, lambda decreases. Now, similarly on this side, when you go that way, to the left, the frequency decreases, right? So I'm interested in the wavelength for this question. Now, how can you use this sort of acronym here and this placement to answer this kind of question? Well, to use C as an example, 4 times 10 to the 2 is far too big to be an ultraviolet wave because that's somewhere on the left-hand side, perhaps radio or micro, right? So you can use your general knowledge of the spectrum, knowing that the highest wavelengths are here and that the highest frequencies are here, to piece these questions together. However, before your exams, just make sure that you know the rough values of where things go, because if not, you'll be quite stuck. So that's question 1. Right, question 2. Which term is not used in either of Kirchhoff's 2 laws? Our good friend Kirchhoff, right? Now, he's got 2 laws. The first law is that the sum of currents in a junction equals sum out of junction. So if I have a wire and that splits off like that, if I have 2 amps here, I'm going to have 1 amp there. I must have 1 amp there. The current is conserved going in and out, right? Okay. So in his first law, I'm using current, so that can't be right. Now, the second law of Kirchhoff, if I draw a little circuit to demonstrate this, and let's say I've got some kind of resistor there, right? The EMF here equals the voltage here in a closed loop, right? EMF equals sum of voltage. And that's for any closed loop in a circuit. You know, if I had another circuit like that, and I had 2 resistors instead of 1, let's call these 1 and 2, then 1 plus 2, the voltage of 1 plus the voltage of 2, equals the EMF. So anytime you have a closed loop in a circuit, the EMF equals the sum of the voltage drops across all the components. So what terms am I using here? I'm using EMF and I'm using voltage. So that's out. Potential difference is another way of saying voltage, so D is wrong. Therefore, A must be the correct answer. And that's for question 2. Question 3. The diagram below shows the refraction of light at the boundary between 2 transparent materials, X and Y. The refractive index of material X is that, and the refractive index of material Y is N. We don't know that. Which of the following expressions is correct? Okay, right. So this looks like Snell's law, which is at its base, N1 sine theta 1 equals N2 sine theta 2. So the refractive index of the boundary you are coming from times by the angle of incidence, sine of the angle of incidence, equals the refractive index of the boundary you're going to times sine of the angle of refraction. Now, the angle of incidence and refraction are measured from the normal, right? That's really important. Because if I look at my diagram, this angle of 20 is not the angle of incidence. This angle is. And that's 70 degrees because we've got 90 here. 90 minus 20 gives me 70. Now, why is this angle in the angle of incidence and this one not? Because this is the angle between the ray and the normal. Whereas the 20 degree angle, let me just get rid of that. Whereas the 20 degree angle is the angle between the ray and the boundary. And that's not what we want. We want the angle between the ray and the normal. So if I look at this angle here, this is correct because it's the angle between the ray and the normal. So that is my angle of refraction. So if I plug my values into this equation, I'll have 1.5, the refractive index of x, times by sine of 70 equals n times by sine of 50. So, do any of them match up? Yeah, C does. So C is the correct answer. So for this question, I think a lot of people could get caught out because they'd use 20 as the refractive index, or sorry, the angle of incidence, which it isn't. Remember, angle of incidence and angle of refraction are always measured from the normal to the ray. Let's move on. Question 4. A student is carrying out the Young's double slit experiment using visible light. The distance between the slits and the screen is kept constant. That's important. The wavelength of the light is lambda and the separation of the slits is A. The following results are collected by the student. Which combination of lambda and A will give the largest separation between adjacent bright fringes? So we know our double slit equation. If you don't, it's in the formula book. Lambda equals AX over D. Now X is our separation between the fringes. Now we want to find that, so let's rearrange for X, and that's the fringe separation, right? So I'm going to have lambda D over A equals X. Now I'm told in the second line that the distance between the slits and the screen is kept constant, so I can cancel off D. Therefore I can say that lambda over A is proportional to X. So all that means is that this relationship here is equivalent to this relationship of X, right? So if I want the biggest value of X, I need the biggest value of this relationship of lambda over A. So what I can do is I can just put the values in for each of these, see which one is the biggest, and that's my answer. Don't worry about the units, right? Nanometers and millimeters, because we're finding equivalent values. So we're not finding one exact value, so you don't need to worry about the units. So if I do 450 over 0.2, starting from A, I get, 450 over 0.2. I did it wrong on my calculator, I apologise. That's 2250, right? If I do 510 over 0.15, I get 3400. If I do 550 over 0.25, I get 2200. And if I do 610 over 0.3, I get 2033.3. So the biggest answer is B. Therefore, the separation between the fringes will be the biggest when we use B. Therefore, B is the correct answer. I hope that made sense, guys. Right, question 5. A car of a mass of 1,000 kilograms is travelling on a straight horizontal road. The car driver applies the brakes. The speed of the car decreases from 20 to 15 in 2.4 seconds. What is the average power dissipated by the brakes? Right, we know that power equals energy transferred over time. Now, if I want the power dissipated, that's the energy dissipated over the time, right? Now, how can I find energy? Well, I can find the kinetic energy here because I've been given speeds and I've been given a mass, and EK equals a half mv squared. So to find the power, I can do the energy dissipated, which is the difference in the kinetic energy, so the change in KE over the time. Well, that's equal to a half mv squared 1 minus a half mv squared 2 over 2.4 seconds, which is the time. So therefore power is a half m. I'm just factorising a half and an m. because they're constant in each term on the numerator. So I'll have a half lots of m over v squared 1 minus v squared 2 over 2.4. You don't have to do this step. You could just put your values into this equation and be safe. But I'm just showing you guys a shortcut so you don't have to type a longer expression. So I'm going to put that into my calculator right now. And I'm going to have the half of the mass, which is 500, times by the first velocity, or the first speed squared, which is 20 squared minus 15 squared over 2.4, which gives me 36,458, which is approximately 3.6 times 10 to the 4, which is C. And I hope that made sense, guys, for question 5. Right, number 6. Two coherent waves are emitted from the sources X and Y. The diagram is not to scale. The waves at X and Y are in phase. The waves have a wavelength of 4 centimeters. The phase difference of the two waves meeting at P is that, 270 degrees. Which row gives possible distances for A and B, right? So, 270 is a weird phase difference because it's not constructive and it's not destructive either. Because 180 degrees, a phase difference of 180, is destruct. I'll just call it destruct as a shorthand for destructive. And 360 degrees is construct. Again, just a shorthand for constructive. Now 270 is in between these two values. So it's neither fully destructive or fully constructive. So we need to find values for the path difference that is not a whole number of the wavelength or a half of the wavelength. Now, I'll explain what I mean, because with the path difference, path diff for short, for constructive, we need n lambda. We need a whole number of the wavelength. For destructive interference, or destruct for short, we need m plus a half lambda, right? Or n lots of a half lambda. So, if I get values which correspond to these two here, they can't be right, they have to be wrong. So, to find the path difference, that's just A minus B, or B minus A, it doesn't really matter, but let's do that here, right? If I do, for A, if I find the path difference, 26 minus 20, that's 6. For B, that's 22 minus 20, that's 2. For C, that's 18 minus 15, that's 3. And for D, it's 14 minus 10, which is 4. Now, starting from A, right, 6 over 4, which is the wavelength, 4 is the wavelength, is equal to 3 over 2, which is a multiple of a half, right? 3 over 2 is equal to a destructive interference. Because it's n plus a half lambda, right? You know, it's 1.5 is 3 lots of a half, right? You can think of it like that. So that's wrong. Now, number 2, or B, we have 2 over 4, which is a half, which is definitely destructive, right? Now for C, we have 3 over 4, which is 0.75, or 3 lots of a quarter. Now that's not constructive or destructive, so that's our answer. Because if it was constructive, it'd have to be a whole number of 4, but it's not. And if it was destructive, it would have to be a value of a half of 4, which it's not. So C is the correct answer. And just to check, 4 is wrong as well, because 4 over 4 equals 1, which is a whole number. So therefore, C is the correct answer. That is, it's a bit of a tricky question actually, but if you can understand this, that what corresponds to a destructive and a constructive interference, you should be fine. So moving on to question 7. Right, question 7. A resistor of resistance 12 ohms is connected in parallel with another resistance of a resistance R. The total resistance of the circuit is 4 ohms. What is the value of R? So we know that for two resistors, or however many resistors, in parallel, the equation to find the total resistance is 1 over R total equals 1 over R1 plus 1 over R2. So R total is 4, so 1 over 4 equals 1 over 12, because that's one of the resistors, plus 1 over R. So 1 over 4 minus 1 over 12 equals 1 over R, and therefore 1 over R equals 1 over 6. Therefore, flipping both sides, R equals 6, which is B. And that is for question 7. Right, let's move on to question 8. A cell of electromotive force 1.2 volts is connected to a wire of resistance 6 ohms. Okay. The potential difference across the wire is 0.9 volts. What is the internal resistance of the cell? Okay, so pretty standard question here. We know that EMF is equal to the terminal voltage plus IR. Now, IR is the voltage or potential difference lost across the internal resistance, right? That's what IR is. So the EMF, remember we talked about Kirchhoff's second law before, and this is an application of that. The EMF is the voltage across all the components plus the voltage across the internal resistance. So if we want to find R, let's rearrange for it. EMF minus the voltage over the current equals R. Now we're given this and we're given this, but we're not given the current. However, we can figure that out. Let's go back to the old school equation, V equals IR, rearrange for current, I equals V over R, and I'm given the resistance of the wire is 6 ohms, and the potential difference across the wire is 0.9. So to find the current in the wire, that's going to be 0.9 over the resistance of 6, which if I do on the calculator, 0.9 over 6, which is 0.15. Therefore, I can put into my full equation now. I'm going to have EMF of 1.2 minus a potential difference of 0.9, or a terminal potential difference, I should say, over 0.15, which is the current, and that gives me little r. It's 1.2 minus 0.9 over 0.15, and that is exactly 2 ohms. So that's C. And let's move on. Right, question 9. A thin metal plate is free to rotate in the vertical plane about the point P. 4 forces A, B, C, and D act at the same point on the plate as shown below. Okay, the diagram above is drawn to scale. All the forces are in the vertical plane. The forces have the same magnitude but act in different directions. Which force will produce the greatest moment about P? Okay, so what do we know? We know that moment is force times distance, right? And for the moment, what makes it special is that we need the force that is perpendicular, I'll just call it FP for now, times by the distance from the pivot. So if I have a pivot here, imagine I have a beam. The force, let's say I have a force going like that, right? Now, if I want to measure the moment due to this force here, I'm not going to take the value of the force. Let's call it x, right? And let's say this is an angle of theta. I can't just do x times the distance from the pivot. I have to do x sine theta times by the distance from the pivot, because the moment is the distance times by the perpendicular component of the force. So I have to resolve all of these forces into a component that's perpendicular to P. So for example, C will not be the right answer because it has no component perpendicular to P. It's completely parallel. So it's not even going to produce a moment, right? For example, so we know C is out. B and D can be resolved because I can resolve B into a force going that way and a force going that way, like that and that. And I can do the same for B. However, it's just occurred to me, A is the right answer because all of A is perpendicular to P. Therefore, all of the force of A, and we were told that all the forces have the same magnitude. So all the magnitude of A can be used to find the moment from P. So A is the correct answer. And that's because it's perpendicular. So imagine that's the line. We've got P there. A is completely perpendicular to P. Therefore, A is the right answer. B is going off in that direction. So I have to resolve B. I have to resolve B like that. And that's the value I'd find, which is smaller than B itself. And D is like that. So I have to find that component, which is smaller than D itself. So A is the correct answer. I hope that made sense, guys. Right, question 10. A total of that many electrons flow through a wire in that time. What is the current in the wire? Okay, so we know that Q, the charge, is equal to IT. However, the charge is also equal to the number of electrons times by the charge on one electron. Now, because I've got two equations for the charge, I can set these equal to each other, removing Q. So I can say that IT equals NE, because both these equations equal Q. So from here, I can rearrange to get the current. I can say that I equals NE over T. Therefore, if I plug that into my calculator, just put all the values in. Remember, E is 1.6 times 10 to the minus 19. So I'm going to have 3.8 times by 10 to the 7 multiplied by 1.2 times by 10 to the minus 6 over, 1.6 times 10 to the minus 19 on the top. And then over the time, which is 1.2 times by 10 to the minus 6, my apologies, we should get, an answer of 5.1 to the minus 6, right? I got 5.066 times 10 to the minus 6 in my calculator, and that is approximately 5.1 times 10 to the minus 6. So that's our answer there, which is C. Okay, question 11. An electric motor is used to lift a weight of 4 newtons through a vertical height of 0.9 meters in 1.8 seconds. Okay, the efficiency of the motor is 20%. What is the electrical power supplied to the motor? So we know our efficiency equation, and I'm going to call it F for short, equals the total power or the useful power output, so the power out, over the power in, or the energy in, it doesn't matter which way or what we say it is, times by 100, okay? So all I need to do is rearrange for the power out. So F, or the efficiency over 100, times by the power in, which is this, equals the power out. Or I've just realized we need to find this. So I'll rearrange this again. That the power in equals the power out over the efficiency over 100. Okay, so how do we find the power out? Because we've got efficiency and we've got this 100, right? How do we find the power that's going out? Now, we can do that by looking at these values here, the 4 newtons, the 0.9 meters, and the 1.8 seconds. Because we know that power is energy transferred over time. And we can find the gravitational potential energy because it's rising through a height, okay? So that is GP equals mgh. Now, if you come down here, and just because there's more space, GP would be 4 over 9.81, or actually I don't have to do that, would be 4 times by 0.9, right? Which would give me, on the calculator, 3.6 joules, right? So to find the power, that's simply 3.6 over 1.8. As we said here, power equals energy transferred over time. So 3.6 over 1.8, that equals 2, okay? So to go back to this equation here, I'm going to have 2 over 20 over 1,000. Over 100, sorry. Cross that out. 2 over 20 over 100, which gives me 10. And that corresponds to D. So the answer is D, right? Question 12. Plane polarized light is incident perpendicular to a vertical polarizing filter. The polarizing filter is rotated about the horizontal axis. Which property of the transmitted light changes as the filter is rotated? Okay, so imagine I have my vertical polarizing filter, and let's say I have light which is plane polarized, but let's say it's also polarized vertically. In this case, the light can pass through because it's orientated in the same direction as the filter. Now let's say I rotate the filter, like in the question, and now my filter is horizontal. Well, if I still have vertical light, it's not going to go through because it's perpendicular to the filter. So what's going to change is the intensity, because waves can no longer get there. So the answer is B, right? The frequency is not going to change because that doesn't affect the number of waves being produced per second or coming towards the filter per second. Nor does that affect the speed, and nor does that affect the wavelength. So the answer is B. Right, question 13. A load is suspended from two wires P and Q as shown below. Both wires have got the same diameter. The table below shows some data for these two wires. So we have the length, the Young's modulus, and the extension of the wires. What is the extension of the wire Q? Okay, so the Young's modulus, or E I'm going to call it because they've called it E, is equal to the stress over the strain, right? Now, stress is equal to force divided by area. And strain is equal to X, that's extension, over the original length. So the Young's modulus equals the force over the area over the extension over the length. Therefore, the Young's modulus, if I just tidy that up, is FL over AX. Now, there's a couple of things that could be cancelled out here. One of those is the force, because the load is the same for both wires. So F is constant, and both wires have the same diameter. And I know that A equals pi d squared over 4. Therefore, the cross-sectional area is also the same. So, E equals L, sorry, I can't say equals now. I can say that E is proportional to L over X, okay? Now, in P I had L and E, but in Q I've got 1.5L and 3E. So, E is going to be proportional to L times by 1.5 over E times by 3. And if I do 1.5 over 3 in my calculator, that's a half, right? So 1.5 over 3 equals a half. Therefore, it's going to be a half of the extension of P, and a half of 4 is 2. So the answer is A. Right, moving on, guys. Which graph best represents the way in which the resistance R of a negative temperature coefficient thermistor depends on its temperature, theta in degrees Celsius? Okay, well, straight off the bat, it's A, right? Because it's an exponential relationship. As R or as theta increases, R decreases at a changing rate. It's not constant, okay? And it certainly doesn't increase, right? So C and D are wrong. So this is a question which you really just have to learn the answer, and that is A, right? Moving on. Question 15. A student balances a uniform metal rod horizontally. The rod is pivoted at its middle. The position of weight W is kept constant. The distance of the weight F from the point is X. The student changes F and then adjusts X so that the rod remains balanced. Which statement is correct? Okay. So we know for this rod to be balanced, the moment due to the weight has to be equal to the moment due to F. So the moment due to weight, I'll write it like that, has got to be equal to the moment due to F. Now moment equals force times distance. Therefore, the moment due to the weight has got to be equal F times by x, which is the distance in this case. So if I increase f, then x must decrease, because I have to balance it out. You know, if I increase both these variables, then it's not going to be equal to the moment due to the weight. Because remember, I have to keep the moment due to f here equal to the moment due to the weight to keep it balanced. So if I increase x, I have to decrease f. And if I, increase f, I have to decrease x. So they are inversely proportional. And if you look at our answers, that is D, right? That corresponds to D. So D is the correct answer. Now, for example, A is wrong because A is saying that f over x will be a straight line through the origin. Well, if one increases as the other increases, then it's going to far outweigh the moment of the weight. So that's wrong, right? As is B, that's just wrong. And the weight W is equal to fx. No, the moment of W is equal to fx, not the weight on its own. So the weight times by the distance to the pivot times by D is equal to fx. So that's wrong as well. So D must be the right answer. Right, moving on to question 16. The IV characteristics of two components R and L are shown below. Which statement is correct? Right, starting with A. R and L are both filament lamps. That's wrong, right? Because the IV characteristics for a filament lamp are something like that, right? In the positive region of the graph. Now R is a fixed resistor because R has a IV characteristic like that. So R is not a filament lamp. So that's wrong. Okay, B. R and L have the same resistance at 1.5 volts. 1.5 volts is here. If I go up, that's right, because they have the same current, okay? And we know that V equals IR, therefore I equals V over R. So R equals V over I. So to have the same resistance, you have to have the same voltage and the same current, which they have at 1.5 volts. So B is the correct answer. Moving on. The photoelectric effect can be demonstrated using a gold leaf electroscope. The zinc plate of the electroscope is negatively charged. UV radiation incident on the zinc collapses the gold leaf. What is removed from the zinc plate by the incident radiation? Electrons, yes, right? It is A. That's just the basic concept of the photoelectric effect. We know we have metals, or we have electrons on the metal surface. A photon comes in, interacts with one of the electrons, and it removes that electron. So the answer is A. It's not ions, it's not photons, because that's what we use to remove the electrons, and it's not protons, right? That's just wrong. So it's A. Right, question 18. What is the total energy E gained by n electrons travelling through a potential difference of V? Right, so energy equals work done. And the work done slash the energy when you're moving through a potential difference is equal to the charge times by the voltage. Now this charge is the charge total. It's the total charge, right? So the energy equals, let's say the energy on one electron would be 1.6 times 10 to the minus 19, because that's the charge of one electron, times by V. Now, to get E across all the electrons, I just need to times that by N. So which one corresponds to that? That's a D. So the answer is D, right? Question 19. A student is experimenting with sound waves of a wavelength of 3 centimeters and electromagnetic waves also of a wavelength of 3 centimeters. Which statement is correct about both of these waves? A. They can be polarized. They can't, because sound waves are longitudinal, right? And longitudinal waves cannot be polarized, right? These waves, the EM waves, can be, but the sound waves can't. So A is wrong. Right, moving on to B. They can both form stationary waves. That is indeed correct. Both longitudinal and transverse waves can form stationary waves. So B is correct. C is wrong because they're going to have different speeds. You know, sound typically 340 meters per second and EM waves 3 times 10 to the 8 in a vacuum. So, V equals F lambda. If they have the same wavelength, then V is proportional to F. So the speed and the frequency are directly proportional. So if the speed is different, the frequency will be different. And we already know the speed is different just from basic waves facts, right? So therefore B must be the correct answer. And the last question, a laser emits a uniform beam of light. Which two quantities alone are required to calculate the intensity of the beam of light? Okay, so we know that the intensity is equal to the power transferred per unit cross-sectional area. So we just need these two terms. So A is amplitude and frequency, that's wrong. B is cross-sectional area and power, that's correct. The answer is B, right? Energy and time, no. Frequency and wavelength, no. So the answer must be B. And that brings us to the end of this first part of the